This is Mission Control Houston. The Expedition 37 crew has had quite a busy week over the past few days. It all began on Monday as the Albert Einstein Automated Transfer Vehicle 4, that's ATV 4, undocked from the aft port of the Zvezda service module. The departure of ATV 4 ends 4 months linked to the complex and the delivery of more than 7 tons of food, fuel, and supplies for the station's residents. Undocking took place on Monday at 3:55 a.m. Central Time. That vehicle will be deorbited and burned up in the atmosphere on Saturday morning this weekend, and that will end its mission up to the International Space Station. Also on Monday, Mike Hopkins, while all this was taking place, took part in the spinal ultrasound experiment. This is one of the human research experiments that the crew participates in. It uses ultrasound technology to take measurement of the crew member's spine. The goal of the experiment is to help determine and better predict changes that happen to the spine on orbit. The crews sometimes get a little bit taller while they're up there, and that tends to increase the lower back pain and other things that they may suffer through, but they've seen up to a 3% increase in height while they're up in space. So in order to better predict that, this spinal ultrasound takes a look at their spines and their anatomy just to figure out if they can better predict who might go through those changes and who might not, just based on their body type. On Wednesday, Oleg Kotov and Sergei Ryazanskiy worked in the Russian segment to set up and resize the Russian Orlan spacesuits that they will use on the November 9th spacewalk. They're going to be stepping outside with the Olympic torch in a ceremonial spacewalk. Of course, we'll have live coverage of that here on NASA television. That spacewalk will begin at 8:30 a.m. Central Time, 9:30 a.m. Eastern Time. Hopkins also worked with what's known as the SLAM-D device. This stands for Space Linear Acceleration Mass Measurement Device, or SLAM-D for short. It follows Newton's second law of motion by having 2 springs generate a known force against a crew member. While they're mounted on an extension arm, this results in acceleration that can be used to calculate the subject's mass. So basically, it's a fairly complicated way for them to weigh themselves up in space. Of course, you can't really just step on a scale since there's no gravity up there, but this device is accurate to 0.5 pounds and has a range from 90 pounds up to 240 pounds, so it takes care of pretty much everybody. But again, they weigh themselves periodically throughout their expedition on board the station, and it just helps the scientists on the ground monitor their health. Nyberg spent the day on Wednesday retrieving some samples from the Melfi. This is the minus 80-degree laboratory freezer for ISS. It's a giant refrigerator and freezer that the crew stores samples. There's different drawers that are located there that are at different temperatures, and periodically they need to move them from one temperature to another and also prepare them for the return back to Earth as those samples come back for scientists to take a look at. Mike Hopkins also worked with what's known as the reversible figures experiment. This takes a look at how the crew members actually see 3-dimensional objects. They rely on different visual cues and perspectives while they're up there. The scientists and researchers have noticed that tends to change while they're up there. Their perspective tends to change while they're off the planet and in the absence of gravity for up to 6 months. So they basically take a test. They take a look at different images that are almost optical illusions like you've seen on the ground here, where if you look at it a certain way, you see one thing, and you sort of concentrate your eyes, you see a different thing. They do this. They've got a sort of a trigger in their hand, and they indicate using some buttons in their hand which image they're actually seeing. And by answering that test, the ground teams can kind of see what their eyes are seeing while they're up there. And that data is downlinked and helps better understand how those vision changes happen. And this morning, Friday morning, the Soyuz 35 was relocated from the Rosvet module over to the Zvezda service module by Fyodor Yurchikhin, Luca Parmitano, and Karen Nyberg. Undocking took place at 3:30 a.m. Central Time, and docking took place at 3:54 a.m. Central Time. The move of the Soyuz spacecraft clears the way for the arrival of the Soyuz 37 spacecraft with Rick Mastracchio of NASA, Mikhail Tyurin of Roscosmos, and Koichi Wakata of JAXA on board. Mastracchio, Tyurin, and Wakata are scheduled to launch from the Baikonur Cosmodrome in Kazakhstan at 10:14 p.m. Central Time on November 6th. We've got a full day worth of coverage here on NASA television as we take a look at what's ahead in terms of our broadcast. Again, that launch time is at 10:14 p.m. Central Time on November 6th. We'll be bringing you live coverage of all those activities as this crew launches on that day, heads up to the space station. They got about 6 hours to get up there. Our launch coverage will begin at 9:15 p.m. Central Time. Again, the launch at 10:14. Docking coverage will begin at 3:45 a.m. on November 7th, with the actual docking taking place at 4:31. Hatch opening will begin at 6:15 a.m. Central Time, with the actual hatches being opened at 6:40. And then we'll have a video file at 8 a.m. Central Time. A few days after that, on November 10th, as Fyodor Yurchikhin, Luca Parmitano, and Karen Nyberg get ready to come home, we've got a full day's worth of coverage as well. The farewell and hatch closure coverage begins at 1:30 p.m. Central Time. The actual hatch closure will take place at 2. Undocking coverage begins at 5 p.m. Central Time, with the undocking about 26 minutes later at 5:26. Landing coverage begins at 7:30 p.m. Central Time. The deorbit burn that will bring this crew back into Earth's atmosphere occurs at 7:56, and then actual landing takes place at 8:50 p.m. Central Time. That'll be 8:50 a.m. the next morning there in Kazakhstan, and then we'll have post-landing activities and a video file beginning at 9:30 a.m. Central Time here on NASA television. If you missed any of this, just log on to nasa.gov/station and take a look at what's ahead, as we have a very busy few weeks ahead with a lot of comings and goings on board the International Space Station.